Have you ever been puzzled by a warning in your C++ code? It can be frustrating when you encounter issues that seem to have no clear explanation. If that's you, you're in the right place. Today, we're diving into the topic of member shadowing in derived classes and why compilers might not warn you about it. I completely understand how confusing it can be when your code behaves unexpectedly. You might be wondering why your derived class member is shadowing the base class member without any warnings. You're definitely not alone in this. Many developers face similar challenges. Here's the specific situation we're looking at. One user recently asked, "Why does my derived class member shadow the base class member without a warning?" They provided an example where a derived class has a member variable that hides a member variable from the base class. Sound familiar? Let's explore this together. So what's going on here? In C++, when a local variable shadows another variable, compilers typically issue a warning. However, when it comes to class members, the rules change. This can lead to unexpected behavior, especially if you're not aware of it. Let's break it down. And stick around. At the end of this video, I'll share a tip on how to avoid these shadowing issues in your own code. To address the issue of member shadowing in C++, the user should first understand the concept of shadowing. Shadowing occurs when a derived class member has the same name as a base class member, which can lead to confusion. Next, the user should consider using different names for the members in the derived class to avoid shadowing. This practice enhances code clarity and prevents unexpected behavior. The user can also utilize the using directive in the derived class to explicitly bring the base class member into scope. This allows the user to access the base class member without ambiguity. Lastly, the user should be aware of the compiler settings. Some compilers may have options to enable warnings for shadowing. Checking the compiler documentation can provide insights into these settings. Fun fact, did you know that C++ was originally designed to add object-oriented features to the C programming language? It has evolved significantly since then, but some quirks like shadowing still remain. Now, let's look at the answers provided by other users. This user explains that the virtual keyword allows the caller to decide which function to invoke. However, since the function in the derived class bMemberVar is not overridden, the base class function aMemberVar is still called. Here's a tip to avoid shadowing issues. Always use unique names for your member variables in derived classes. This simple practice can save you from confusion and unexpected behavior down the line. And there you have it. Understanding member shadowing in C++ can help you write clearer and more predictable code. If you found this video helpful, please subscribe for more programming tips. And don't forget to check out our next video for more insights.